Uh, Hello all. So in this video, we'll look at regarding the evaporative loss control device. So in short form, we call it as ELCD. Now before going to look at the controlling of evaporative losses, but at least we should know what does this evaporative loss means. You know, in general, we'll have uh, uh, petrol tank, carburetor, so and some sort of the connecting from petrol devices to other part of engine. Since petrol is highly evaporative in nature when compared to the diesel, so some part of petrol, so it converts into vapor form and then it releases into atmosphere. Okay, so it is accounting some percentage of hydrocarbon in atmosphere. So we need to control such evaporative losses from an vehicle. So this is what an overview of the what is evaporative loss means. You know, uh, if you look back or if you just recall in one of our introductory classes of emissions, we have discussed that so some uh, percentage of uh, carbon monoxide, hydrocarbons, NOx, etc. from for a vehicle, isn't it? So, and we also know the sources of carbon monoxide, hydrocarbon, NOx, isn't it? And this hydrocarbon already, so we know that in second unit we have briefly discussed about the sources of hydrocarbon, isn't it? So out of the uh, n number of sources for contributing hydrocarbon formation. So this evaporative losses or two devices will also contributes to this hydrocarbon in the form of uh, vapor. So this evaporative losses comes under the hydrocarbons. Okay, and this accounts for nearly 10 to 15 percentage of total hydrocarbon emissions. Okay, so if at all we take 100 percentage, so other percentage like some X percentage from we already discussed the sources. So in that we have maximum of 15 percentage from this evaporative losses itself. Okay, so that's why so people have started controlling this evaporative losses. And there are some uh, figures or the statistics which tells that how much amount of hydrocarbons in the form of evaporative loss is released into atmosphere, and this is mainly given by the refueling stations. Okay, so for example, if you take the Russian, they have reported that so nearly greater than 140,000 tons of hydrocarbons were emitted per year. And Germany, so they have reported nearly 145 the same units. And then England does nearly 120k tons. So this much amount of hydrocarbons in vapor form is in the atmosphere. And we'll discuss what are the sources are responsible for this formation. So the main sources for this evaporative losses are, the first one is fuel tank losses. The second one is carburetor losses. Okay. Now we'll discuss these two losses separately. Okay. The first one is here fuel tank losses. Okay. Now we'll look what is fuel tank losses means. So this is the complete setup for the evaporative loss control device. So this is like without carburetor. So we don't see here the carburetor. Okay. Now what does this fuel tank losses means? Now for uh, a few minutes we'll discuss only the losses only. So we don't discuss the controlling. If you just look at here, so this is your fuel tank, and here we have two vent. So this one and this is where the vapor liquid separator and filler tube connected to the fuel tank. The second vent is ventilation pipe. Okay. Now this is fully sealed. So this is must. So we should use the sealed field cap. Okay. Now how the fuel is get vaporized in this tank? You just take that. Consider the engine, was continuously running for hours. Okay. So since the modes of heat transfer, so one of the mode can lead to raise the temperature of the fuel tank temperature, isn't it? Now once the temperature of your fuel tank, so whatever, so this in different modes the temperature it gets raised, right? Now due to the increase in temperature, so already some of amount of air is occupied inside your fuel tank. Okay. Now due to rise in temperature, so what happens, your gases will get expand. Okay, so it will expand to the corner points of your fuel tank. Now since it is there is a passage, it will try to escape in this vent. Okay, and then goes clear. Now this air which is expanded it will always mix with the your gasoline vapors. Okay, so your air plus gasoline vapors. Now that mixture will be settled. It will go till the top. Okay, so now since it is sealed, now just we will be dealing here only. So we don't go to the other part. Now once the temperature decreases, now what happened? It will contract. Okay, so once it gets contract, what happened? The tanks gets cool. Now what happened? Again, the flow will be changed into reverse mode. Okay, so whatever the space, the gases which is accumulated at the uh, periphery of the tank, it will comes down. It means it is creating more space again. Okay, so this uh, like expansion and then contraction of mechanism is call it as breathing. Okay, so we call it as breathing. So just like to take as uh, uh, human. Okay. Now once it gets contract, what happens? There is a more space inside the tank, right? Now what happens? The air enters the tank from the atmosphere and then ventilates it. Okay, so this process itself we call it as breathing. Okay. Now, whatever the due to the rise in temperature and the ventilation of air, so both will be settled only on the in the empty space of your fuel tank. So once it is goes to your this part, that is your vapor liquid separator and filler tube. So here it gets separated. Okay, so this is how your fuel tank will uh, like contributing for evaporative loss. Now what happens? So if it is goes unsettled at this area of weight. So once your whatever the vapor of gasoline goes here, so once if it is not sealed, so let us take example, your vehicle, the fuel has ended up and then you are going for the fuel station to refill the tank. Now you just open the cap. What happened? Whatever the vapor which is settled here, so because of increase in temperature, so once it gets open, the gasoline in vapor form it comes out, right? So once this is get empty, again the fresh air enters and then occupies the place here. Okay, so that is how your fuel tank is uh, contributing the evaporative loss. Now we'll see how the carburetor is uh, contributing to evaporative loss. The second type is carburetor losses. Okay. And by this time, uh, you would have know how the working of carburetor. Okay. And majorly the operation of engine. You want to increase the RPM levels or the power of engine. Okay, so you need to provide more amount of fuel inside the carburetor through float chamber. Okay. Okay. So once the what the throttle is connected to your float chamber, and then again it how much amount the pedal, if you press too much, the float chamber will release too much of fuel, and then it goes through the chamber. Okay. Now the engine stops running when the fuel has been completely utilized. Okay. Now again in the float chamber, so your carburetor, as I said in the fuel tank losses, because of continuous running of engine, okay, it will also produces the heat. Okay. And now this heat may also reach to the carburetor. So, and obviously in carburetor we have the float chamber. Okay. Now, so this in float chamber, the more amount of fuel is stored. So because of its uh, temperature is increased in the float chamber, so we'll have the fuel in a vapor form. Okay. So this is how the carburetor is contributing to the evaporative loss. So if at all total evaporative loss, so this carburetor alone contributes to the 10 percentage of uh, hydrocarbons to the uh, like atmosphere. Now we have seen two major sources: fuel tank losses and then carburetor losses. But these are the sources, and how these sources, in what are the ways the fuel is escaping from this sources. Okay, so we'll see those. So there are like four ways in which petrol vapors are produced and allowed to escape. The first type is diurnal evaporation. So what does this diurnal evaporation means? So diurnal evaporation means, so if you just take the vehicle, so which is if you take uh, in summer, so in summer if you just the afternoon, the peak temperature where you achieve, right? So the vehicle is exposed to the whole body of vehicle is exposed to the uh, atmospheric temperature. So and the temperature is changes depends upon the weather condition. It's a morning or afternoon and night. Okay, and our concern is majorly the noons, the afternoons. That too in summer season, the temperature at afternoon will be much higher compared to the other seasons. And then what happens? So due to that atmospheric or ambient temperature, your fuel tank. So whatever the fuel tank, so this temperature will be increased. Okay. Now, because of this increase in temperature, what happens? Your vapor in the fuel tank gets formed, increase in vaporization. So this is what your diurnal evaporation means. So it occurs during the daylight hours. Now, the second time, that is the running losses. So running losses in the sense, let us take this is your engine. Now, so if you want to like the get the fuel, you need to connect with the uh, fuel tank. Okay, and now same thing. It will also will be comes from the uh, exhaust. Okay, now what happens if your engine is continuously running? Okay, so due to increase continuous operation of engine, the temperature will be increased or the rise in temperature occurs. Now, because of the connections between your fuel tank and the engine, okay, so the mode of heat transfer, your temperature of fuel tank will be increased. Okay, and now, so this temperature is this cause the fuel vaporization. So this is what your running loss means. Third type, that is hot soak. Now, hot soak means again, so we take, so this is the engine and somewhere you have the fuel tank. So again, so just think that we have the uh, exhaust system somewhere, exhaust system this is. Now, what happens? Again, assume that your vehicle was running for continuous hours and then it is turned off. Okay. Now, even though the engine is turned off, uh, the moment it turned off, the temperature of engine will not reduce drastically. So it takes time, like if you take the graph, temperature versus time. So it takes time to come to the lower temperatures, right? So, but so due to this time period, okay, so the engine will be in hot condition itself. Now that hot or that temperature is enough to generate the radiation. Okay, so that radiation from the engine and the exhaust pipe, at the same time we have the ambient. So all this one, so two and three will increase the temperature of fuel tank. And due to this, the fuel vaporization takes place and then it is contributing in that way. The fourth type, or that is refueling. So the term refueling itself, so once your tank, fuel tank gets empty, so you'll go to the fuel station to refill. So assume that this is the fuel tank. Okay. Now once your tank get empty, so what happens? Whatever the earlier the three types: the diurnal loss, running losses, hot soak conditions. So everything will lead to increase the temperature and the vaporization of fuel. So that fuel in vapor form, it will be stored in the, like, the periphery, the top, isn't it? Now once when you go for refueling, what happen, you will open this cap. So once it is open, it is exposed to uh, atmosphere and then comes out of the uh, cap. Okay, so and this is how the refueling is contributing to this losses. And these are the four ways uh, the fuel can escape from the different sources, that is a fuel tank and then carburetor. And now we have understood that how the evaporative losses occurs in the vehicle. Now we need to control this loss. So that is what our the whole purpose of this concept. Now how to control this? So for example, so just to draw a simple diagram in a line sketch, so we can, with the carburetor, so assume that, so this is your carburetor. This is your fuel tank. And from fuel tank, so we, it is sent to the another compartment, that is vapor liquid separator. Vapor liquid separated. And the losses occurred in both fuel tank and then carburetor is sent to a common device, which is known as canister. Okay. And from canister, we will send this to purge control valve. So PCV stands for purge control valve. And this is sent to inlet manifold. So the overview of how the evaporative loss is controlled is in this showed in this line sketch. So whatever the losses, vapor comes from the carburetor is sent to the canister, and from the fuel tank is also sent to the canister. So from canister, it is directly sent to the inlet manifold. And this is a rough way to tell that how the evaporative losses is controlled. Now we'll see that how we will control this uh, evaporative losses. Yeah. Now, just before that, we understood that this part, how to, how the losses occurred in a fuel tank. So, and same concept is also applicable with carburetor also, and both the things can be connected at same place. So as of now, we are dealing with without carburetor. Okay. Now what happened? Uh, Now whenever the seal cap is open, the uh, vapor is escaped or from the pipe. Okay. Now we don't want to waste this hydro or the vapor form of hydrocarbons, isn't it? So that is what our purpose. So we want to utilize the hydrocarbon in order to uh, or in I'll just put it another way, that we don't want to go outside or just emit in the atmosphere, but we want to make participate into the combustion. Okay. Now assume that this is whatever the four ways of losses, like diurnal evaporative loss, and then running losses, hot soak, refueling. So everything after uh, rise of temperature of fuel tank, it is get vaporized and then stored here in the vapor liquid separate tank. And now what happens? It is, since it is sealed, it goes into this channel, and now it is enter into the charcoal canister. So this device, which we call it as charcoal canister, so where inside we have the shell, okay, the charcoal bed, which we call it as, okay. And we have a filter here. Okay. Now once the vapor which is entered into this uh, charcoal canister, it will be settled in the inside your charcoal canister. Now what happens? This charcoals have the like hydrocarbon absorption capacity. Okay. Now once like the engine runs for continuously for hours, the amount of vapor or the losses occurred in the sources comes and settled here. Okay. Now how this is going to be utilized? Now what happened when the engine is in suction stroke, means from like TDC to BDC. So when the piston moves from TDC to BDC, what happens? The suction stroke takes place, which means it sucks the air. Okay. So the air enters. So this is air filter from the atmosphere. It gets sucked. Okay. Now it means it is creating the vacuum or negative pressure. Now at the same time, it also has an effect on the charcoal canister also. So once it gets sucked, whatever the hydrocarbons absorbed by the charcoal, it will be released, okay, because of its negative pressure. And then see, it will absorb or it will be released here into this. Okay. Now once uh, so whatever the stored or the vapor in charcoal canister, it will come through these channels in during the suction stroke, and then it will be mixed with the air. So at one direction we are getting air, or so since this is SI engine, so we can have the air fuel mixture. Okay. So this hydrocarbons will be mixed in this inlet manifold, and then okay, since we have uh, injector here, so only it is comes along with the air, sorry. So it is mixed here. So first the hydrocarbon mix with the air, and then later it mixes with the charge, and then it is entered into the combustion chamber. Now, once the piston moves from BDC to TDC, so due to increase in pressure, so and then the temperature rises, and then the charge will get burned. Okay, and then it comes from out of the outlet, the exhaust hole, and this is how that we are controlling the uh, evaporative losses. So whatever the losses, so for example, so consider that uh, somewhere here we are connecting the carburetor. Okay, so both from the fuel tank we are not allowing the the losses, the vapor form of fuel into atmosphere. Instead of that, we are making use or allowing to participate in the combustion. So this is how we are controlling the evaporative losses. And now there are some other uh, statistics, no, not so that is some values which tells that how much percentage uh, yeah, so contribution of hydrocarbon emission uh, of various components of evaporative emission control system. Okay, like fuel feed line, return fuel return line, filler hose, and then vent lines, evaporative lines, filler gap, and packing, fuel damper. So just have a look at those uh, components, how they are contributing to this evaporative loss. Thank you.